It seems like every few months, the evolutionary biology community has something new to get excited about. Scientists keep finding evidence of incredibly old life. Like in March this year, researchers found remnants of ancient thermal vents buried in rocks in Quebec with microfossils that clocked in around 3.7 to 4.28 billion years old. These would have taken the crown for the oldest fossil ever, but a lot of scientists think that the original estimate was off by like a billion years. So we're still looking for more conclusive evidence of super old life, and this week, a group from Denmark thinks they have some. Partially buried under the ice and snow of West Greenland, there's a belt of rock called the Isua Greenstone belt. In the 1970s, geologists dated this belt to be over 3.7 billion years old, some of the oldest rocks on Earth, and for years, scientists have been probing the belt for evidence of ancient life. In 2016, researchers found signs of some really old fossils called stromatolites, which are sediment layers made by bacterial mats. The wavy shapes and textures of certain layers looked similar to other stromatolites, but there wasn't enough proof of organic material to suggest that they were actually made by microbes. And now, researchers might have that proof, or at least more clues. The authors of this new paper, published in the journal Nature, used a technique called vibrational spectroscopy to figure out the composition of tiny pockets in the Greenland rocks. Specifically, the researchers looked at garnet inclusions, which are minerals that got trapped inside the rocks while they were being squished by heat and pressure. Within the garnet inclusions, there were small pockets of organic leftovers, and when scientists bombarded these pockets with infrared light, all of the molecules and atoms started to vibrate at really specific frequencies. Using those frequencies, they can tell which atoms are bonded to each other, and they found evidence of carbon bonded to nitrogen, oxygen, and probably phosphorus, which points directly towards life. The more research we can do on these rocks, the better, but these fossils are looking pretty much like the oldest evidence of life we've ever found. So far. Now, while a bunch of scientists search for the oldest life on Earth, others are focusing on keeping modern-day organisms alive. Researchers at Caltech have figured out a way to speed up a chemical process in the ocean that normally takes thousands of years, and this reaction could help us combat ocean acidification. The amount of carbon dioxide gas in our atmosphere is steadily climbing, and it's one of the big players responsible for climate change. But the biggest concentration of CO2 isn't in the air around us, it's in the ocean. CO2 is soluble, which means it easily dissolves in water, and the amount of gas in the air directly impacts how much gets into the water. Once it's in the ocean, carbon dioxide reacts with water molecules to form carbonic acid, which then breaks up into carbonate ions and hydrogen ions. And here is where a complex chemical balancing act comes in. See, carbonate and hydrogen ions can combine to make bicarbonate, which is much less acidic, so it can neutralize the dangerous concentration of acid in the water. But bicarbonate isn't super stable either, so it'll keep splitting back up into carbonate and hydrogen. We call this the bicarbonate buffer, something that helps moderate pH levels. The exact same process is happening in your blood right now and keeping your body working properly. Now, as the amount of atmospheric CO2 increases and more gas dissolves in the ocean, the bicarbonate buffer starts to wobble, which is a huge problem for organisms that rely on chemical balance to survive. But according to this new research, there might be a solution scientists have been overlooking. On the bottom of the ocean floor, there's a graveyard full of the calcium carbonate skeletons of billions of dead sea creatures, like corals or plankton. Over thousands of years, these skeletons dissolve, releasing their carbonate back into the ocean, adding to the bicarbonate buffer. But right now, with so much ocean acidification, the natural reaction rates are way too slow to help neutralize all this extra acid. In our bodies, these kinds of reactions can't and don't take thousands of years to happen because we have an enzyme called carbonic anhydrase that catalyzes that reaction. So the researchers at Caltech thought, hey, maybe we can use this enzyme to kickstart some chemistry on the bottom of the ocean floor too. And after running some experiments in the lab, they found that it can make the slow part of the calcium carbonate dissolving reaction around 500 times faster. So it's not a magic bullet fix to ocean acidification, but this research could be the first step in making some antacids for the whole ocean. By boosting the bicarbonate buffer, we might be able to combat one of the biggest and nastiest effects of increasing CO2 levels. Thank you for watching this episode of SciShow News, and thank you especially to all of our patrons on Patreon who make this show possible. If you would like to help us keep making videos like this, you can go to patreon.com/scishow, and if you just want to help us out by watching, because there's lots of great stuff here, you can go to youtube.com/scishow and subscribe.